Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. Do you realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world? Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night. And good evening to anyone who's watching and also those on the stream. And please, if you're on the stream, let us know where you're coming in from. That would be absolutely fantastic. And if you've got any questions along the way, please chuck them into the chat. Just start off with Acknowledgement of Country. In recognition of the deep history and culture of this island, we would like to acknowledge and pay our respects to the Tasmanian Aboriginal people, who are the traditional owners of the land upon which we are presenting right at the moment, the Muwinina people. So, now what we've got tonight, we've got a little bit on magnetic loop antennas, a little bit of design and bits and pieces, and some great resources around magnetic loop antennas that I will I'll take you through and show you. These are all online, and the design ideas that I've got for an HF magnetic loop antenna, using some bits and pieces that are reasonably easy to find. A little bit about the Old Timers News. Radio Amateurs Old Timers Club of Australia produce a fantastic magazine. We have featured it here before, and there's some great articles in here that I want to go through. So, and if we've got time, then the QRP magazine is the other thing that I want to actually show you. So, and hello to Andrew from Signet 73. Great to have you on there. I was actually down in Signet on Saturday. We did a training and assessment day with a couple of scouts from the Signet Scouts. So there you go, down in that beautiful part of Tasmania. Now, loop antennas. Magnetic loop antennas are shrouded in lots of myth. I think that's how I'd best describe it. They're quite simple antennas to make. You make a loop or a hexagon or a square or a circle or all sorts of different configurations. there's usually some sort of variable capacitor arrangement with them, so you can do a little bit of tuning, the inductor on the loop and then the capacitor. And then there's a little inductive coupling, usually a little inductive coupling coil that you connect the coax to. So that's another bit of mythology that I seem to see a lot of comments about. And these things have phenomenal. The one great thing about them is they have phenomenal directivity. So you can put these on a rotator and actually null out local noise quite quickly. They can cover the whole of the HF bands all the way up into VHF and UHF. In fact, the 70 centimetre beacon that we run down at Snug has a loop antenna on it with a little gamma match for 70 centimetres in a horizontal arrangement. So yeah, you find them all over the place. So my idea was I was given a wonderful couple of coils of LCF 1250J Heliax. Now this is the 1250, the 12-50 is 12.5 millimeters in diameter, the outside diameter of the Heliax, so it's half-inch Heliax. And it's all copper inside, copper outside on the Heliax. So great to be able to silver solder to or solder to, so you can get that resistance right down. And I'll explain and show you on the chart what that actually does to the antenna. And I happened to come across, and I've shown this on a previous night, a vacuum capacitor up at Ross at the Meet the Voice barbecue. And this vacuum capacitor gives me, I think, 5 to 200 picofarads. It's motor driven. There's a little shaft that you can drive the plates in and out of each other. And it's all in a glass envelope, very nice glass envelope. And the price was the price was good and wasn't the new price, which I suspect was an awful lot of money. So I thought, I've got the Heliax, I've got the vacuum capacitor. I need something that helps me design a magnetic loop antenna. Well, there starts the adventure. And I'll put the URL to this particular web page. This is VK3CPU, which is Miguel, who has this wonderful application on his web page, which takes into account all of the equations for a magnetic loop antenna, and there's an awful lot of them that you can take into account. And it in real time plots as you put in the parameters, and you can see, let me go over here, you can see here there are a whole bunch of little sliders here at the bottom. Actually, it's just off the bottom of the page here, but anyway, there's a whole bunch of sliders here which represent, there are things like the diameter of the material you're using, it's the diameter of the loop, the number of loops, because he's actually built in here so you can have more than one. You can actually have a little, its own little Heliax of a couple of loops. There's a couple of other parameters in there. There's the transmitter power, and then the resistance of the loop as the very last of the sliders, and then you can put in metric or imperial, and whether the material's copper or aluminium, and whether it's circular, octagonal, hexagonal, or square. And it all wonderfully takes into account all of these parameters. All of these scales down the side, and you can see this one right on the edge is picofarads, so that's the capacitor that you put on there. The next one in is the voltage that appears across that capacitor, which is good because the vacuum capacitors are rated to a particular number of 1,000 volts. There is the bandwidth for the particular frequency you're looking at, the efficiency in percentage, and then we head over here, and we've got the perimeter, the wavelength, the internal resistance, the reactive resistance, so the reactance measurement, the Q of the loop, how many amps run through it for the particular transmitter power that you put in, and the very last scale, which I'm not quite sure what that is, but I'll find out what that is and I'll report back. Oh, the wavelength. The wavelength of the coil, of course, that's lambda. It just doesn't appear very well on my my little printed output here. So just to show you, there is this second slider down here is the diameter of the actual loop. If we start increasing this up, you can see we're up to 1.3 meters, and we can keep going up here, and you'll notice that as we go up in size, the frequency scale down the bottom is starting to come down, and we're up to 2.3 meters, and you can see that this is 10 megs, that's 12 megahertz. Now, what it really nicely does here is, for each of the emitter bands, it comes up with a little sheet, parameters sheet for each of those particular emitter frequencies, and you can see here's the 3.5 to 3.8. So it gives you one for the lower part of that band and one for the upper part of that band, and it gives you a whole lot of little parameters, which are all of these scales on the side. And you can see for a 2.37 meter diameter with a diameter for the actual material of 12.4 millimeters, it gives you for 3.8 megahertz, which is the top of the 80 meter band. The tuning capacitor needs to be 227 picofarads. There is what's the next one? Voltage on the capacitor. Okay, this is 3.82 kilovolts. The bandwidth is 4.45 kilohertz. The efficiency is about 5.5%. And then it goes through the other parameters, the reactance, the Q, the current running through. So for 100 watts, there is 22.4 amps running through this particular coil, and the perimeter is a fraction of a wavelength at 80 meters. So you can hover over these particular areas, and it gives you for each of the emitter bands the parameters. So this is really handy because I've got a 5 to 200 picofarad vacuum capacitor. So what I want to do, I really want to cover at least 20 meters, and also I want to cover 30 meters, so 10 megs and 14 megs. So they're the two that I'm mainly interested in. So if I come down in and I get to, let's start with about 1 meter in diameter. So you can see the frequency scale's gone up because we've come down in size. The upper one here is 25 megs. So this gives us the 12 meter band up the very top, and then we come down to the 15 meter band. Then we come down. There's the 18 megs, and then down to now here we go. This is what we want. This is the 20 meter band, so the 14 megs, and it's the top and the bottom of the 14 meg band. And then it goes all the way down, and we even go down to 630 meters, which is not very efficient. We're in the 0.001% efficiency down here. So what we can do is, with a 1 meter, we've got the upper frequency limit is the 12 meter band, so 24 megs. and the capacitor, the tuning capacitor, has to be at about 5 picofarads, so it's right on the edge of what I've got. Let's keep coming down the ammeter bands, keep coming down until, okay, let's come down, this is 40 meters, we're at about 267 picofarads, so we're 267, our capacitor only goes to 200, so we can't cover the 40 meter band. We can cover the 30 meter band. We get to 14 megs, so 20 meter we can cover. Let's go up, and this was about 5. So with a 1 meter diameter, we can cover from 12 meters to 20 meters with the capacitor we've got. So let's keep coming down a little bit here. We come down to about I can't actually see what that says. Just bear with me, because I'll pull it in and make sure I've got that at the right level. Here we go. So it's pretty touchy. Okay. So that's about, let's pull it back in here, that's about 0.9 of a metre, so 900 millimetres. And you'll notice it's gone up in frequency, so we actually get the 29 meg band, so 11 metres. We've got 10 metres in here, we've got 12 metres, all the way down. So let's have a look at what the capacitor is up here. Now this is about 4.28 at 11 meters. Now that's 28. Top of the 28 meter, so this is 10 meters. Top of the 28 meg band, we're at about 5.75. So we're within the capacitor's ability. Let's keep coming down. So we get down to 20 meters, which I do want to cover. That's about 43 picofarads, so fantastic. Let's come down to okay, 7. So there's our 30 meter band. We're at 50 odd picofarads, so fantastic. We come down to 40 meters and we're at about 185 and 205. So we just cover the 40 meter band, probably not the low end of the 40 meter band, but maybe the high end of the 40 meter band we could cover at 200 picofarads. That's not a bad arrangement. So about 0.9 millimeters, 0.9 meters, sorry, 900 millimeters, at 12 with a 12.4 millimeter diameter material, which is the heliax. We can cover from 28 megs all the way down to almost all of 40. So if we went a little bit smaller, we could probably cover the whole of the 40 meter band. So that's getting to about 0.889 of a meter, about that size, with the capacitor that we've got. So fantastic. Now, sorry, one of the things I wanted to show you is, one of the key things with a magnetic loop is to try and get the resistance down to as low as you can get it. And one of the key things here is, and I'll just I put in, you put in the resistance that you think that you can achieve, and I put in 0.1 ohms. Now I can measure 0.1 ohms, so I thought, okay, that's a bit of an aspirational number. 0.1 ohms. Now this bottom scale we can actually, and what I might try and do here, can we, yeah, there we go. So this bottom scale, let me just scroll down a weeny little bit. That's it. This bottom scale here is the resistance that you think you can achieve. As that resistance goes up, you'll notice that some of the parameters change quite significantly. If you can achieve a resistance, a zero resistance, then efficiency goes up, voltage comes down, all sorts of things happen. But I think I reckon I can achieve with silver soldering everything up and making sure the brackets make good contact with the vacuum capacitor, etc., etc. I reckon I can probably achieve 0.1 of an ohm, and I can certainly measure 0.1 of an ohm. That's one of the key things here. I can actually measure that I'm getting that. So with some copper brackets and fairly tight fitting, and then silver soldering everything up, I think I can probably achieve 0.1. So that's pretty reasonable. A transmitting level of about 100 watts is all I've got available to me anyway. So that's within the limits of the vacuum capacitor, which is fantastic. And the 12.4 you can see here, and then the 0.9 of the diameter of the material. So what I'm thinking about doing is, I then thought about how do I mount all of this on in such a way that, number one, I can rotate it, which is a bit of a challenge because you've got a loop of material. So a bit of a mud map here of drawing. This is the vacuum capacitor here. There is a large base that you connect to here, and there is, in fact, let me try and get. That's better. Look at this. We go to negative, it comes out better. So this is the vacuum capacitor here. It's got a small top on it and it's got a larger base on it. So where the loop comes up, what I'll be doing is there'll be a small copper plate silver soldered onto the end of the outside of the heliax, and then it will bolt onto that top cap. Similar arrangement but slightly longer down here to the bottom cap, silver soldered here and here. This loop, this is a 90 millimeter plastic PVC pipe that I will cut a slot into, very similar to this, which it will sit in. That will form part of the mounting, and there'll be a cap on the top of the PVC pipe. The shaft here, what I'm actually doing is running a piece of fiberglass all the way down to and out below the actual loop, so it gets everything outside the loop all the way down to the bottom here. Where the loop goes through the PVC down here, there'll be a slot in the side, so it will slot in, and there'll be a PVC cover that will go over that to provide a little bit of waterproofing. Both at the top, it'll be the top cap that will cover it, and then at the bottom there'll be a side cap. And then basically below the loop will be the motor drive and the limit switches and everything for the vacuum capacitor, so I can get my 5 to 200 out of the vacuum capacitor. So that's what I'm thinking about, and then there'll be an arrangement at the bottom here connected to a rotator, so you can rotate it and get directional coupling. Now, how do you couple to it? Because that's great. You've got a loop. You've got you've actually got a tunable loop. Fantastic. But how do you get energy to it? Now, I'll put the link to this particular article in the notes. It's in the notes now for this video. presentation. There is a wonderful and quite descriptive, lots and lots of information around this. Most of them use inductive coupling. So there is a loop of about a fifth of the diameter of the main loop. That seems to be the magic number. And it is inductively coupled. So there is you can see here this is a schematic of what you're looking at. You've got the tuning capacitor at the top. You've got the main inductive loop, which is it takes into account the inductance here and here, the series inductance. There is a coupling loop, an inductive coupling loop that goes off, and depending on how you set up that inductive coupling loop, there's a couple of different types. These are the unshielded coupling loops using coax. So RG213 or the like, you can use as a coupling loop about a fifth the diameter of the main loop. And there's a couple of different configurations you can use here, but the key thing is it's the outside. You can see here on the middle one, it's the outside of the braid that you're using, or it's the inside just as a wire, as an open wire. The advantage that this one's got is it's actually shielded, insulated with the outer plastic of the coax. Or you can use the inside, but you need to actually have you can't connect that together here. That defeats the purpose. You need a break in it, and you use the inside with the braid taken off, or the braid's going to be shielding it. Now that's the unshielded coupling loops. There are what they call, and they're different arrangements with there's a loading capacitor here. That's the tuning capacitor, and there's a loading capacitor here to null out some of the inductance. Then there is you can stretch or compress a round coupling loop around the actual loop, so it's much more closely coupled. There's some novel ones here. The coat hanger coupling, which is a little bit like the gamma match, which we'll go into in a sec. And the coat hanger then goes off to a piece of coax and a well, either a balun, or it could be a balun / impedance matching transformer. There is some twisted spiral type coupling here, where at a number of turns around the outside, 40 turns single stranded heavy insulated wire. This is now the shielded coupling loops. So this is again using coax, but you actually cut a slot out of the coax, and here you can see it swaps over from the outer to the inner, so that you actually get half of that loop is via the braid, and then it goes into the actual wire down here, and then this is, it uses the braid, but you'll notice it's still got a slice out of it at the very top. Whole lot of different ways of doing this, variations of shielded coupling loops, and it makes an interesting point here. Of course, you could use a T connector, a B and C T connector, and connect it together. Can I just say, do not use this configuration, because what you're doing is basically shielding the inside wire with the outside here. You're not. It's effectively doing this with a whole lot of shielding around the outside, so the inside's not picking up anything because the braid's shielding it. Whole lot of different balanced shielded loops. There's the Mobius strip that changes over at the where the slot is at the top. Balanced, so these are exactly the same on both sides in a balanced arrangement. Of course, if it's a balanced arrangement and you want to connect coax to it, you've got to have a balun in there. So there's the one-to-one balun, which comes out with a B and C. Whole lot of different mounting arrangements that he goes through here. Whole lot of different techniques. The orientation of the coupling loop he goes through, and all the different There are capacitive coupling methods where you actually have a tuned arrangement, well, not a tuned arrangement, a matched arrangement. That's a better way of putting it. So you can match to the loop. And here's a little a tuning and matching unit of the Patterson loop. This looks very similar to an antenna tuner, automatic antenna tuner, which would have a whole lot of relays along this bank of capacitors, which are increasing in size. Magnetic transformer coupling using ferrite or powdered iron rings. You can put a ring around the main loop and then put a loop through that ring, much closer coupled, and also then do an impedance transformation on the way through. You can see here. So lots of different ways to couple to the loop. Most of them you've probably seen are inductively coupled, so there is just a little loop next to inside the main loop and matched accordingly. So I'll put a link to that particular article because many ways of connecting, as well as I'll put a couple more links in there, which are some other magnetic loop references that I came across in there as well. So good reference material, and good. There's some great notes in there about actually building the loop and how to get over a few issues when you actually build the loop. So anyway, magnetic loops. That's watch this space. The magnetic loops are being created right at the moment. So there you go. And by the way, the 160 meter short vertical, doing some ground plane experiments with that over the next couple of days. Thank you to our government for giving us a day of mourning. I'm going to mourn in a particular way with a 160 meter antenna. So there you go, and so that'll be written up and submitted to AR magazine. So we've got it in. We've got a record of the experiments that have been done. So watch this space now. Old Timers News, fantastic magazine. If you have been licensed for more than 25 years, you can actually get full membership of the Old Timers News, or you can get associate membership. And yeah, then there's a whole lot of other different types of membership in there as well. So there you go. Now, I just wanted to go through a few articles in here, and I've actually got some show and tell in relation to a couple of the articles, because I opened it up and I went, oh, I know what that is, and I happen to have one in my collection. So yeah, really well put together magazine, and there is a funny arrangement here. That one of the first articles in the magazine is a farewell to two RAOTC stalwarts. Now, this particular man who is presenting, David VK3ADM, David and his wife Pam are actually coming to the Tassie Ham Conference and Expo. So David is currently the president of RAOTC, so he will be down. And here he is presenting to Bruce Bathels, VK3UV, and also Ian Godsall, VK3JS, who have contributed a huge amount to the Radio Old Timers Club and the magazine as well. So there you go. So we go on. There's a wonderful article in here. The active life of Bill Rice, who was VK5BP and now VK3ABP, and Bill started and Bill was the editor of RAOTC magazine for a long time, and he had an interest in sailing. and started in South Australia, and this article has a wonderful recollections of him sailing his yacht on Lake Eyre. Now, for those who don't know, Lake Eyre is in the middle of nowhere, in the middle of South Australia. Only feels when there is an awful lot of rain in the outback. And in fact, if Alan VK3KAJ's in the studio, I suspect he will know what I was talking about, and may have even seen water in Lake Eyre. I know my old man and my mum have certainly seen water in Lake Eyre. It is a huge lake. We are talking this scale down here. This scale is 100 kilometres across. So it is more than 100 kilometres across, and well and truly more than a couple of 100 kilometres long when it fills. So it is a huge, what many of the explorers called the inland sea. This is an article with some recollections about Bill Rice sailing his yacht on Lake Eyre, there is even the Lake Eyre Sailing Club, the clubhouse here. So anyway, great article. Now the next one, and this is one that. By Herman Willinson, who is a collector, a Morse key collector, who I have bought a number of, at least a couple of keys off of. For those who don't know, I collect Morse keys. And he talks about Wood Borer's 8 Herman's Morse key. Now, this particular Morse key is a standard issue PMG key, which is what I've got in my hot little hands. And you can see it has a marvellous piece of wood on the bottom of it, and the particular one that Herman's talks about here has been eaten away by wood borers, and you can see just a comparison. The comparison is there's Herman's key. And here's my key, and it's very similar. I actually have a terminal that comes out the top here. That one there is extended out to a terminal. Herman's does have the shorting bar on it. You can see the shorting bar here. Mine actually doesn't have the shorting bar, and so that's what the back terminal is all about. So there you go. So article about eating my key. I just heard something fall down next door. Anyway, John Daniels selecting the piece of wood to replace the key. So there you go. Now they've had a continuing story about Radio Australia at Shepparton. This is part 3. So that's been an ongoing article, and quite a number of the RAOTC members actually worked at Shepparton. Refurbishing a Collins R390A by Mike Charteris, which is this guy here. He's written a number of articles for AR magazine. Another one by Herman, Wires Without Wires, about the movement from wired Morse to wireless Morse. And a bit of history around that. Marconi in his laboratory, Marconi and his wife Christina at the time, and his steam yacht Electra, which features in a lot of historical documents. Listings of the members. Now there are a couple of obituaries that in this article, and one I just point out here. This is Tom Moore, VK7 Fox Mike. And Herman VK7HW, who's a member of RAOTC, wrote a wonderful obituary for Tom that is printed in this particular edition. Now, celebrating 90 years of the ABC's Australia's public broadcaster, And when I opened it up, the first thing I saw was Prime Minister Joseph Lyons. Now, Prime Minister Joseph and his wife Enid Lyons, of course, were Tasmanian. He's the only Tasmanian Prime Minister that we've ever had back in the 1930s. So there you go. That jumped out at me. The lizard-dew figure, which ended up becoming the ABC symbol from the oscilloscope. Two-way communication. Now, this is wonderful. This is by Carol Lee, VK3CPU. Now, he talks about two-way communications in vehicles. These are valve sets, a number of the Pi walkie phone, the Pi PTC. These are all valve sets. The Pi Cambridge, which is starts into the solid state. Now, my old man VK5TW had a Pi reporter that he used to use as a doorstop. I remember in the shack, I used to stub my toe on it because it had a terrible pointy bit on the chassis. But anyway, and then into people will recognise the FM92s. I've still got a couple of them that are in service. The old technology versus the 3.6 meg handheld, the Motorola phone, TAC phone, and then we've got the Motorola DTR 550 digital handheld / phone. So great article. Radio V&G, which was Australia's own time and frequency system. A bit about Samuel Finley Breeze Morse. So Samuel F.B. Morse, A Patient Waiter is No Loser by Herman Willinson. Wonderful article. And then finishes up with celebrating 100 years of the BBC. So the ABC is celebrating 90 years and the BBC is celebrating 100 years. So there you go. So fantastic magazine. Old Timers News, the Journal of the Radio Amateurs Old Timers Club of Australia. So well worth a look. And the RAOTC website, which is worth a look because every Monday night on the let me go here. Every Monday night on the here we go. The RAOTC website. Worth a look. And every Monday night, first Monday night of the month, we have the RAOTC broadcast, which is a great broadcast. Lots of historical things on that broadcast, and it goes out on RJG and RAD. So there you go. So that's the RAOTC broadcast. Now, when I dug this out and found this. I found a wonderful little. Would you believe it was back in the 80s? A wonderful little, and you'll see how small this is. I need to zoom in. That's a business card, and this is what's called a BHC Birdie key, a Z73 miniature key. It actually was made in, I don't know whether it's still made, but it was made in China. Wonderful little key. You can see that's the size of my finger, so it's smaller than my finger. And this is number 385. It's got full control of the spring and the gap and the little bearings in here. And then it's got a couple of little terminals on the back, a little bit of Teflon on the bottom. But a Birdie BTC key, I didn't remember what the box was, so it's what the modern Chinese ham is using. And I bought this quite a long time ago. So a wonderful little, it's actually probably quite a good key for doing SOTA or something like that, where you only need a small key that doesn't take up much room and doesn't take up much weight. But anyway, there you go. A little birdie BHC birdie key Z73 comes in a cute little container too. But anyway, that's a bit of an aside. I found that when I was looking for the other key. So how are we going for time? Okay. What we might do is we might finish up there. And hang on, let me just consult my notes so I don't forget anything. So, what we might do next week is we've got it must be magazine month. We've got the Low Key magazine, which is the VKQRP Club magazine, and I noticed I haven't even taken it out of this plastic. The Amateur Radio magazine appeared in my letterbox today. There's a wonderful, actually, let me just open this up. I'll just very quickly show one thing out of this magazine, because, just bear with me. There is 57, 56, there is, okay, so there is, push the button, a wonderful ad for the Tassie Ham Conference and Expo. So we got into this edition with the Tassie Ham Conference and Expo down at the university, which is a fantastic segue into the Tassie Ham Conference and Expo is happening on the 5th and 6th of November. The 5th is a presentation day, and the 6th is a ham expo. Huge prize pool. Just want to emphasise the prize pool. We've got an IC705 and backpack. We've got a Rig Expert AA650 Zoom antenna analyzer. We've got a $250 gift voucher from TET Mtron. We've got a Nano VNA. We've got a 250 watt LCD power SWR kit. We have a full 122 gig transceiver to give away. Compliments of 5KK, Dave mentioned. We've got some Yaesu merch, and we've got some wonderful handmade pens, conference pens, that are very wonderfully and kindly donated by Rick VK3CPU, who makes these pens. So and we've got some other goodies as well that are in there as well. So huge prize pool, and the only way that you can get into the raffle is if you come along to the conference and or the expo, and your ticket includes one raffle ticket, and then you can buy extra tickets at the events. So it's the only way you can get into the raffle. So that's the Tassie Ham Radio Conference and Expo, and I'll stick the link in the video description, so you can just go there and there's one click and you can book for the event, etc, etc. Quick reminder, Sunday the 9th of October 2022 is the Military Radios and Antennas number 2 with Kim Briggs, VK7KB. Now he's bringing along a whole bucket load more of his his military radios, for amateur use. For amateur use that he didn't get to last time, as well as quite a number of the military antennas, and we're actually going to be setting the antennas up out in the compound, so and see what sort of techniques the military use for their HF and above antennas. There is a BYO barbecue on there, starts at 12 noon, and then the presentation starts at 1. So please come up if you're interested. have a snag, and then get into military radios and antennas. And then the conference, 5th and 6th of November, if that hasn't been drilled into you enough. Anyway, that's our program for tonight. Hope you've got something from it. I'll just have a look. Tom. Okay, Tom George. Great read. Yes, for the. I assume that's for the OTN news. Fantastic read, and well worth. I usually sit down and start reading it, and suddenly realise that it's an hour or two has gone past. Great, absolutely great read. So good stuff. Anyway, I hope you got something from tonight. That's our program. We'll keep you updated on how we go with the magnetic loops, and then we've got some things in store for our coming nights. I'll take calls on R2, and that's same time and same frequencies next week, and same stream, and we'll see you next week. This is VK7OTC for the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night 73, and we'll catch you next time.